Yeah. So collision is the situation in which more than one element can be stored in a single bucket of the hash table. So this is the situation. So it makes difficult to store the element and to retrieve the element also. So to avoid this one, some techniques have been introduced. So this is very important concept. Collision resolution techniques. To resolve this collision problem, some techniques have been implemented. They are separate chaining is there and open addressing is there. So you just note down some concept. Am I audible to you?
Yes, sir.
Yeah. Just it is very important one. Collision resolving things. I think I'm having a problem with my board. Collision resolving techniques. Just write down to resolve the collision problem. To resolve the collision problem. To resolve the collision problem. Two techniques. So to resolve the collision problem, the two techniques is introduced. The two techniques are to resolve the collision problem. Two techniques is implemented. First one, separate chaining. Second one, open addressing. Separate chaining and open addressing. And again in open addressing, we are following three methods. Linear probing, quadratic probing, double hashing. In the open addressing, we have three methods: linear probing method, quadratic probing method, and double hashing method. Have you noted down?
Yes, sir. Sir, 1 minute.
Okay.
Sir, okay. Sir.
Fine. So let us see what is separate chaining method and what separate chaining technique and what is open addressing technique. Some problem with the board. What is the method we are following to insert the elements to the hash table? Yesterday we have discussed
The three methods: division, mid-square, digit folding method.
Yeah. What is division method?
To ask the function.
Means what should be done in the division method? Means how this follows.
Like we have to divide in that like h of 11. Names
Simply, no need to say what is h and everything. Simply in the division method, we will divide the element with the size of the hash table. In the division method, we should divide the element to be inserted by the size of the hash table. So in here we will get only remainder. Division modulo means element division modulo size of the hash table. This one division method we are following. So whenever the collision occurs with the division method, then we will choose any of the technique. Consider we are going to discuss about how this separate chaining technique will work. Sorry, separate chain, yeah. Separate chaining technique. How this separate chaining technique will work. Example, you can write the some notes. Separate chaining technique uses linked lists to place the elements into hash table. Separate chaining technique uses linked lists to place the elements into hash table.
linked lists, sir.
Linked lists. We have discussed about linked lists, no? In the previous classes.
Yes, sir.
That word.
Linked
Separate
list.
chaining technique uses linked lists to place or to store to place the elements into hash table.
Elements into hash table.
Full stop.
Okay. Sir.
Using separate chaining technique, we will not place the elements. We will not place the elements directly into the buckets. We will not place the elements directly into the bucket. Full stop. The elements will be stored directly into the linked lists. The elements will be stored directly into the linked lists. Linked lists. linked list corresponding to its bucket location. Corresponding to its bucket location. No need to write whatever the content I am giving now as it is in the exam. If you understand the concept, then you can write your own. This is my own content I am giving to you. What you have written? Manju, please, can you mute yourself? Who is this Manju? Can someone tell what you have written?
Sir, separate chaining technique uses a linked list to place the elements into hash table using separate chaining technique.
Your voice is not clear. Please, someone other one, please.
Separate chain techniques uses linked list to place the elements into hash table. Okay. Using separate chaining techniques, we will not place the elements directly into the buckets. The elements will be stored directly into the linked list corresponding to its bucket location.
Fine, thank you. Now you can see how this can be done. Example. Take some example. If you want to store the elements like 41, 21, 10, 32, and 4, 42, 52, and 20 also. How many elements are there?
8 to 7.
8, fine. So consider your hash table size is 10. Is equal to 10. Just note down the elements and this one also. How this can be done. Can you read the second sentence?
Using separate that one or the matter you have.
It's not clear.
Using separate chaining techniques, we will not place the elements directly into the buckets.
Exactly. This is 9th location. So 0 to 9 will come now. This size is the 10. So we will not store the elements directly into these locations. We can't store the elements directly, these locations directly. So instead, we will use this linked list concept. So how this can be done? What is the size of the hash table here?
8.
10. So 10. We need to take, we will follow division method only here to insert. Whenever the collision occurs, then we will follow the separate chaining. Means what is the division method? What is the element first? 41. 41 modulo size. What is the size? 10. What is the answer?
Answer
1. So the index number 1, you need to store this 41. Where is index number 1? This one. Here you need to create a linked list. Then you need to place the value. What is the value? What is the element? 41. See, you know that linked list, you will have two parts. This is data part and this is address part. Have you understood this or not?
Sir, can you repeat it again?
What is the element? First element is 41. So,
Yes.
So to insert elements in hash table, generally we will follow the division method only. What is division method? You take the element, you divide element with the 10. 10 is nothing but a size of the hash table. If the size of the hash table is 5, then you can divide the element with 5. So in this case, you need to take the division modulo in order to get the remainder. So the first element is 41. To store 41 into hash table, I am taking my hash table size is 10. 41 modulo 10. I'll get remainder as 1. Is it clear till here?
Yes, sir. Now it's.
So this is the location to store the 41. So we have seen that in the separate chaining technique, we will not store the elements directly into the buckets. Instead of the buckets, we will store the element in the linked list corresponding to its bucket location. What is the bucket location? What is the element? What is the remainder we get? 1. So what is the index of bucket? 1. This is the 1. So here we will create one linked list. In the linked list, we will store 41. Next, what is the element?
21.
21. 21. You can divide 21 modulo 10. I'm having some problem with my board. This is also
1.
1. So again, I need to store this 1 here. So I'll create one node again. 21 I'll store here. Done. Next, what is the next element? 10. 10 modulo 10.
0.
0. 0 means here we need to store.
Nodes get increases, no?
Sorry?
Nodes will get increases.
I didn't get it. Please repeat once. Repeat once. Salva.
Yes, sir.
You only asked now?
Yes,
Then
sir.
I asked repeat once what you are doing.
Sir, then I'm asking that the nodes will get increases.
Sorry?
The nodes will get increases, no, sir. Whatever the element will be there in the one storage, the nodes will get increases to next, right, sir?
Yes, yes, yes. So whatever the element will come, we will increase the nodes. Next element is, this is done and this is stored. Next is 32. 32 modulo 10. What it is?
2.
Yeah, 2. Where to store 2? Where is the location of 2? Here. We will create one linked list. This is 32. Next element is 4. If you divide 4 with 10, what will be the answer?
4.
4. Nice. So you can create one linked list here. Store 4 here. Next, 42. If you divide 42 with 10,
2.
answer will be
2.
2. So we will create one linked list here. 42 can be stored here. I remember. Next 52 also. This remainder will also be 2. 52. Next 20 is there. Its remainder will be 0. This can be stored here. So if it is the last node, if you, నేను వచ్చిందాక పంపించదు. Is it clear to you?
Yes, sir.
So the last node, this will be null. This is other thing. This is not an issue that can be done later. How the elements can be stored in the same location. So this is called separate chaining. ఎంతమందికి అర్థం కాలేదు? మీరు మాట్లాడకపోతే ఏమీ తెలియదు. నేను నా పని పక్కన పెట్టుకొని మీ క్లాస్ తీసుకుంటున్నా.
I understood, sir.
నేను అడిగింది ఎవరైనా అర్థం చెప్పండి. సారీ, ఇఫ్ యు ఆర్ నాట్ గెటింగ్ దెన్ రిపీట్ ఇట్ అగైన్. మీరు సైలెంట్గా ఉంటే ఏం రాదు. మీరు చిన్నపిల్లలు కాదు. ఎన్నిసార్లు అడగాలి?
Modulo is confused, sir.
Modulo is confusing. Have you attended yesterday, Nishita?
Yes, sir.
You know division method?
Yes, sir. But what you said now, it is confused.
Where is the confusion? Tell me. From
Third
starting,
one, sir.
which is 10 modulo 10 or 21 modulo 10 or something.
32 modulo 10, sir.
32 ni మీరు if you divide 32 with 10, remainder ఏమొస్తుందండి? Remainder 2 కదా.
What you wrote in that linked list, sir.
2 వచ్చింది. 2 వస్తే 32 ని సెకండ్ లొకేషన్ లో స్టోర్ చేయాలి. ఇక్కడ నా పెన్ సరిగా రాయట్లేదు, బోర్డు సరిగా పనిచేయక ఇక్కడ నేను రాయలేదు, రావట్లేదు, 2 రావట్లేదు. 32.
Here we are not taking the quotient, we are taking the remainder.
Remainder.
Yeah, that is the modulus. I think you are confusing there.
Okay, the problem with my.
Okay, sir.
I'll explain this with the help of small examples then, instead of 10, because this is very, very important one. So we will see once you take separate elements like you consider example elements 2, 3, 12, 13 and 5. Consider your hash table size is 5. 0, 1. Two, 3, 4. Okay, Nishita?
Yes, sir.
Yeah, we are taking what is the size of the hash table? Size is equals to 5. So first element, 2 modulo 5. 2 modulo 5 means 2 only. So means remainder we are taking. So the 2 can be stored in the index 2. What is index 2 here? So you can create a linked list here. And you can store 2 here. Next element 3 modulo 5. 3. So you can be stored. Next 12. 12 modulo 5. Answer will be 2. 12 5 to divide is remainder 2 study. So where is 2 here? You can store 12 here. Next 13 modulo 5. Answer will be 3. So 3 accordingly you can store. Next 5 is there. 5 modulo 5. Answer will be Nanda?
0, sir.
0. So any confusion or any problem? If it is again problem, then I'll explain this one more example.
Q modulus 5 is there, no?
Sorry?
Q modulus 5. 2 divided by 5 is there, no?
2 modulus 5. Yeah.
So as we can't divide that, so whatever the element will be there, that will be our answer, sir.
Exactly.
Okay, sir. Thank you.
Can I erase it this one?
Yes, sir.
Can you write in the exam about this? If you get it?
Yes, sir.
Yes, sir.
Not for the exam point of view, this is important concept. Next one. What is next one? What is the next technique?
Open addressing.
Yeah. Open addressing. What is the first technique in this? First method in this technique?
Linear probing.
Linear probing. So in the direct method, to insert the elements, we will follow the same direct method only. You take the example. So linear probing is the method of open addressing. We can write some notes about these few points.
Excuse me, sir. Can you give the definition of open addressing?
Linear probing is the method of open addressing technique. Linear probing is the method of open addressing technique. This is used to resolve a collision problem. This is used to resolve a collision problem. This is used to resolve a collision problem. This is used to resolve collision problem. It uses a mathematical function. It uses a mathematical function that is h of key is equals to h of key plus I modulo 10. Here I is equals to 1 to
Sir,
yes,
is it a formula, sir?
yes. It's a function, mathematical function. Here I is equals to 1 to size of the hash table. ఎగ్జామ్ లో కూడా ఒక ఎగ్జాంపుల్ క్వశ్చన్ వస్తే మీరు దీన్ని బాక్స్ లో పెట్టాలి. Done, noted? Hello?
Yes, sir. Finished.
Yeah.
Yes, sir.
What is the difference between this direct method and division method and this one? What is the difference in the formula, in the function? What is the difference? Could you find?
Yeah.
The division method,
We are adding
is
and
nothing but the element, whatever you are going to insert. Key modulo, sorry, that's not 10 here actually. Size of the hash table you can write. Key modulo size. You have noted down, no? H of key is equals to H of key plus I modulo 10 రాస్తారు కదా, ఆ 10 కట్ చేసి size of hash table అంటే అయింది.
Yes. I equal to size of hash table, sir.
No, I కాదండి, ఫంక్షన్ ఉంది కదా, mathematical function.
Yes, sir. H of key.
H of key is equals to H of key plus I.
Okay.
Full bracket పెట్టేసి modulo size of hash table, not
Okay.
10.
Not 10 instead size of hash table.
Yes, ఎందుకంటే అది 10 ఉండాల్సిన అవసరం లేదు.
Okay.
ఎగ్జాంపుల్స్ 10 తీసుకుంటున్నాను కాబట్టి అట్లా నేను మిస్టేక్ అలా పెట్టాను. This
Okay.
is direct method. Division method lo we are dividing element with the size, and what we are doing this linear probing, we are taking this key plus we are adding I to this, and we are dividing with this size. So what is the difference between this above two? This is division method, this is linear probing function. What is the difference we can find?
We are adding and
The size of
So
array.
we are adding some value.
Yeah.
We are adding
Plus size, sir.
we are adding
Plus
some
size.
value to the key.
Yes, sir.
Size is same. See, here key is there and here key is there.
Yes, size is same, but we are adding the size of the array, no, sir. Whatever the array size will be given, we have to add that to the key value.
Not the array size. We are taking some integer value. We are adding to that key.
Randomly, sir, or
1 to size. It starts from 1. I'll explain and you'll come to know if you see the example, if you observe the example clearly.
okay.
We'll start this one. See, we will see it once. You take the example to insert the elements or like. You are going to store like 4, 14, 5, 15, 3 you are going to store. So further, normally we will follow division method only. Whenever a collision occurs, then only we will decide which method or which technique you are going to use. So I am going to use linear probing when the collision occurs. So normally we have to divide, we have to do the normal division method only to insert the elements. So here I am taking the array size as, array or hash table, both are same. Hash is nothing but array. So I am taking array size as 5. So this will 0, 1, 2, 3, 4. This is the array size. So first I'll do the same thing like normal method. How to insert 4 modulo
5.
5. We will follow normal division method only to insert. Whenever the collision occurs, that time we will decide which technique we are going to use to resolve that collision. So in this case, what is the remainder here?
4, sir.
4 means the element, this can be stored in the location 4. Now, this is done. Next element is 14. 14 modulo 5. What is the answer?
4.
4, sir.
4 only. But element is there. We have to store. Collision occurs. To resolve this one, I am using this linear probing. What is linear probing method? So, in which location I need to store? So, I will take as key. What is the key? 14 plus I value. I value starts from 1. I is equals to 1. Here, size is 5. No, I value is here 1, 2, 3, 4, 5. I value.
Okay.
So, what is the first value? I value, we will take it as 1 only. 1. What is the answer?
15 by
14 plus 1.
15.
15 modulo 5. Answer will be?
3.
Huh?
0.
0.
So, which element we need to store at 0th location?
14.
14.
What is the actual element? Actual element is 14. So, here 14 will come in this location. Understood or not?
Yes, sir.
Whenever the collision occurs, you add 1 to it and divide with the size and get the location. If that location is free, so what is the location we got here? 0th location. Is it empty or is it having any elements? (14 plus 1, 15, no? 15 modulo 5, we will get 0. 0th location is empty. So we can store 14 over there.
Yes, sir.
Done?
Yes.
Yeah. Now we will go to another one. Next element.
Again, collision will occur, no, sir.
Yeah, we will see whether it is occurring or not. Five modulo 5. Answer will be
0.
0.
Zero.
Zeroth location you have to store. Whether is there any element existing in the zeroth location?
Yes.
Yes. So collision problem is there.
Okay.
So what you should do? 5 plus
I
1. I value from 1 to size. 5 plus 1 modulo 5. What it is? 6 modulo 5. Answer will be
1.
1. So 1 location, index number 1. We have to store the actual element. What is the actual element here?
5.
5. So this one, this is called key. 5 must be stored in. This is free, so we can store it. Now, what is the next element? 15 is there. 15 modulo 5.
0.
0.
0. Zeroth location we need to store 15. Whether it is it empty?
No, sir.
No, it is not empty. So we should go for linear probing. Linear probing means 15 plus 1.
16 modulo 5.
15 plus 1 means 16. 16 modulo 5. What is the answer?
1.
1.
1.
In the is there, you have to do the probing again, sir.
Again collision occurring.
Yes, sir.
So then increase the I value.
We have to take 2.
Yes. Actual element is 15 plus I value start we have taken as 1. You have to take the I value as 2.
So that is 7.
Modulo 5.
Two.
This is
2.
17 modulo 5. So answer will be
2.
2. Whether the index bucket is 2, sorry, index is free or not?
Yes, sir. Free.
Yes,
It is free. So what is the actual element to be stored?
15.
15.
15 will be stored here. Now you can take about 3.
Modulo 5. 3.
Yes.
Directly we can store it.
Yeah, the element is 3 modulo 5.
3 will come. We can store it directly.
Yeah, so you can store it directly. It is empty. So this is the way. Understood?
Yes, sir.
Understood or not?
Understood, sir.
Yes, sir. Understood.
Yes.
See, you observe that if I take I value, if the index is not free, it is having some value. If I take I value as 1, if I do the calculation, I'll get even collision. If I increase the I value 2, even though if I get some value, that location is also full, means having some value, again collision occurs. Then I'll increase the I value to 3. So like this, I can increase the I value to compare all the locations. This is the problem with linear probing.
Okay.
If you take the I value 1, we'll get some value. If that location is having some value, again collision occurs, then we need to increase the I value and we need to check it. If you increase I value, we will get one more location. Even if that location is also full, then again collision occurs. Again, we need to increase the I value. So how many comparisons are required here? In the worst case. Worst case means we need to take all the I values.
Yes, sir.
So that is the worst thing.
Mm.
So that is the problem of linear probing. That problem is called primary clustering.
Primary cluster.
Primary clustering. You can write down. The problem with linear probing.
The disadvantage maybe.
Yeah. The disadvantage with linear probing is primary clustering. The disadvantage with linear probing is primary clustering. Means
You have to go through all the silos.
What do you mean by clustering? See, you can see, no, all the elements have been stored in the nearby only. If we have the size also, like size also 10, the most of the elements are nearby only.
Yes, sir.
And okay, they get a group lag unte. That is the problem. The disadvantage with linear probing problem is primary clustering. That means that all the means we need to make more and more comparisons by increasing I value. By increasing I value. This is the problem. To overcome this problem, we will use another method called quadratic probing. Please come in. Please come in. That is called quadratic probing. So have you understood the concept?
Yes, sir.
Please, if you are not getting, let me know.
Understood, sir.
Linear probing, anybody? If you're okay, then I'll move to the next one.
Yes, sir.
Yes, sir.
Yeah. Actually, see, some classes going on for the second semester students. I need to go there. I'll continue class in the afternoon. Is it okay for you?
Time.
Time, I don't know.
Yes, sir.
Okay, sir.
No, sir, will join back.
It's up to you. If you want to listen, if you join, no issue. This is not mandatory. It's up to you.
We'll attend, sir.
It's up to you. Before that I'll inform you when I'll
Just
be.
sir will
Yes,
join.
okay, sir.
Okay, fine. You can leave now.
Okay.
Thank you.
If you have any problem, please you can make a call regarding this linear probing.
Okay. Okay.
Thank you.
Thank you.
Thank you, sir.